you guys are gonna learn how to do the surface area for a cylinder, right? And just like the last one, you have to figure out what that net is so you can take the individual areas and then go ahead, add them together, find the total surface area for that 3D figure. So here we have our cylinder. We know that this right here is going to be our cylinder, our nice example. So thinking about our net, right? We have a top, we have a bottom, and then we have all the way around. Think about this yellow piece of paper as our label, right? So imagine if I unravel this, that all the way around, I have a rectangle. So right here in my net, I have my rectangle, I have my top, which is a circle, and then I have my bottom, which is a circle as well. Now, if I want to figure out what the length of this rectangle is, that dimension isn't given to me with that cylinder, so I need to figure out what this is. But if I wrap this label around, I figure out that this rectangle, its length, is the circumference of my circle, right? Remember, the circumference is like the perimeter all the way around. So if I wrap it back, it fits perfectly, and that length is the exact same as my circumference of the circle. So when it comes to that dimension, I'm gonna have to find my circumference so I can figure out what that actual length is. All right, so let's go ahead, label our figure. We have our top and we have our bottom. We already know which is the top, which is the bottom, and then that rectangle goes all the way around. So we're gonna go ahead and label our dimensions. First one I see here is we have our height, which is represented by this blue side here, if you guys can see that, and that is 8 inches, right? We also have our diameter. So it is straight across from one end of the circle to the other. We have 10 inches. Same thing for our bottom circle. From one end to the other is 10 inches. Now again, we need to figure out what our length is going to be so we can ultimately find the area of that rectangle. So right now I'm going to highlight that. And I'm going to mark it as capital C. Think for a second to yourself, why am I going to label that capital C? Let's think. Pause me if you need to. All right, I'm labeling it capital C because remember that length is going to be the circumference of my circle. So first I need to find the circumference of my circle so I can find this side here and then find all of my areas, add them together, boom, bam, done. The circumference of the circle. Let's work over here. We have C, capital C, is equal to 2 pi r, right? 2 pi r, which is also equal to 2 times the radius is going to be our diameter, which is represented by D. So right now I'm just going to plug in, but I'm not going to multiply pi in. I'm going to do that later once I find my area of that rectangle. So I don't have to work with too many decimals. All right, so 2 pi r, if I'm looking at my circle here, I need to find out what that r is, my radius. My diameter from one end to the other is 10. I know my radius has to be half of it. So my r is going to be 5. I have 2 times pi times 5, which gives me pi times 10. So that is my capital C, my big C. So now I can go ahead and erase that C that I have here for my length. I'm going to replace that with 10 times pi. Inches. Can't forget that B. So now when it comes to multiplying, finding the area in my calculator, I'm going to do length times width for the area of a circle, or excuse me, a rectangle. Area equals length times width. So I'm going to multiply those together. I get 8 times 10 times, I can't forget that pi symbol that's there, that's part of it, times 3.14. I get 251.2 exactly. So I'm going to go ahead and write it down here, 251.2, because I recognize that that represents the area of my rectangle, and I'm going to have to add that to my 2 bases, right? So I'm gonna go ahead and put that plus sign there so I can start setting that up to find the total surface area. So we already got that one down. I know that I have two circles here that are identical to each other. They are the exact same circle. They are congruent to each other. So I'm shading that in green to remind myself that they are the same. Top and bottom of my cylinder are the same circle. So when it comes to my actual formula, when I'm plugging in, I know I'm going to have to do 2 times whatever I get for the area of those circles. I have to multiply times 2 because I have 2 circles here. So now to find the area of my circle, we all know that the formula for area of a circle, you guys see that I'm putting lower script here, circle, just to remind myself that is equal to pi r squared. We already said that our radius was 5, so now I'm just plugging in. I have pi times my radius squared. We know that 5 times 5 squared is going to be 25 pi. And I cannot forget those centimeters squared. So now in my formula, I'm gonna go back in, plug that in. I have 25 pi right here in my parentheses. I don't want to deal with too many decimals, so I'm leaving that pi right now for my formula. So in my calculator, we know PEMDAS, we know that we have to multiply and then add first. So in my calculator, I'm going to do 25 times pi, 3.14, times 2. I get 147. So the area of those 2 circles together, I have 157, and I'm adding that to the area of that rectangle, 251.2. So my total area is going to be, pause for effect, 408.2 centimeters. We cannot forget the squared because this is area. Remember, this is our area. So all we did was we flattened out our 3D figure. We found our 2D figures that make up this cylinder here. We have a base, our top and our bottom, which are circles. Then we have all around our lateral area. Our lateral figure here is a rectangle, so we found the area of that. At the end, we had to add it all together, creating our formula, which is surface area is equal to L. Remember, L represents lateral area, plus 2B. So remember that 2 represents the fact that we have 2 bases here that are circles, and B represents the area of those circles. So we just created our formula using our net. Good job.